am fortunate today, I feel, and privileged to have an opportunity to go away from a technical talk. I'm sure the conference will offer participants an awful lot of technical talks, but I wanted to speak maybe a little bit more from the heart of what engineering means and should mean for some of us, for all of us, all engineers out there in the world, now and in the future. So, start with some questions. It's commonplace now to have less and less answers. We seek the answers via our AI tools and we pose the questions, but I think the important thing here is to pose the right questions. And the right questions for me today are as follows. Are we sure that with all of the advance in sensing and sensor technologies, all that sensors do for us and for society is for our own good? Are we actually collectively designing a future that serves people? Are we putting people first? Is people the first thought that comes to one engineer in their labs when they produce the next generation sensors? Do we actually have a technology push that's a little bit too strong or far too strong on sensors, on data, on AI? Do we understand what these advances can mean for society at large? And really, what are we here to do as engineers? Carry on as normal? Is it business as usual? Or do we need to see a shift in the way to think in order to deliver that better future that sensors, data, and AI could potentially, at least in my opinion? I feel that in order to answer some of those questions or begin reflecting on them, we ought to look back of how far we have come. We stand here on the edge of an AI world. We are using AI in our lives from the moment we wake up to the moment we go to sleep, in the personal lives, in our professional lives, in the way we educate others, in the way we are educated by others. But this hasn't come from nowhere. Our AI society has come from our advances in sensors, in data, in processing of that data, and harnessing the power of data via cheap and low-cost sensors. So it's a good time to actually look back of where we came and admire ourselves and our progress on how far we have arrived. For me, the journey in sensors, if I may reflect a little bit, has been a very fortunate one. I did start by saying I'm a very privileged person standing here as a private individual and also as a professional. I have joined the sensing community in 1998, January, with my PhD at a time where Sandia Labs were creating the first dust mite size actuators. It was absolutely fascinating. I entered my PhD when the world was driving towards use of AI, very, very incipient, very primitive use of handcrafted neural networks to use them to drive enhanced capabilities in all sorts of areas. I deployed all my research from the same home, Coventry University, which has been an enormously good home for me. And I've been fed throughout my nearly 3 careers in sensing by humility and by the desire to be of service to the world. I do generally and passionately believe that sensors make the world turn around quite smoothly, and the place we live in, we work in, wouldn't be the same without them. Priorities have shifted over time as we progress through the era of sensors towards the era of data and that of AI. At the time where Sandia Lab was producing their first MEMS microchips, the concerns were with reducing size, lowering cost, ensuring repeatability, ensuring that the performance of the sensors that they were producing was consistently so, that sensors were calibrated and the measurement that they delivered was right, was accurate, was precise and repeatable. Those were simple engineering concerns. We had those concerns as long as the engineering profession was there. There's nothing new there, and I think an awful lot of people were very comfortable in that space because we knew what we were seeking, very clearly, very precisely. However, the tide has started to turn when miniaturization reached and met met the radio. At the time when we were able to produce not only sensors and actuators that were so tiny, but also radios that we could put at their back, at their integration output, we started to think bigger. We started to realize that actually, as long as we can communicate data from sensor to sensor and from many sensors to a single point or from many sensors to many points, we actually can harness more of the power. We don't have to worry about repeatability so much. We don't have to worry about accuracy of a single sensor so much, because we can actually calibrate whole host of sensor networks in order to get that particular performance. From there on, I think the world opened to a host of opportunities, the IoT, the Internet of Things, the Internet of Energy, the Internet of Everything, the Internet of Society, and we began connecting people and devices, applications, and actually opening the door to creativity, to ingenuity in engineering that has led to automation, that has led to process efficiency, that has led to widespread measurement in all sorts of areas, from transportation to infrastructure to health and to our journeys in space, if I may say. My own journey in this area also traveled through all sorts of applications. There's hardly anything out there that we haven't attempted to do in our labs, and it's been a very fruitful and very good time, very good years, all the way to a few years back.
Yep, I'm on.
I've never seen this working before. Let's give it a try.
Right, so very proud. That was in Singapore, 2014, I believe. One of our first PhD students on IoT driving the Singapore water flow from one place to the next in a way that is commanded purely by wireless sensors and actuation. So it's production grade science right there, delivered from lab to field in a very short period of time. So once we figured out that we can resolve actually just about every application, we set our mind to, from a sensor and an actuator and a radio end and a front end, we began to thinking about tackling autonomous decision making. And that is actually a very important point and a very important area of work that has no doubt promoted many of the advances in AI that we see today, particularly the advances in analytical AI. So being able to actually devise an on-body system that doesn't need human interaction, that's purely fueled by the sensors, data, by the decision-making on-body, and also able to actuate in order to redress a human's health state in field, was actually, for me personally, a big indicative achievement of what the strength of the technology is when we put together AI, sensors, data, and AI. We then can we can begin to think about the future. We can begin dreaming about what sensors could do in an autonomous fashion, not only on Earth, but everywhere else. And actually, we are not far from realizing a pictorial dream that I put together in 2013, and I think the world in 2030 will have that for real extraplanetary exploration with sensors, data, and AI. But for me personally, I would like to reflect that comes a time when technological advances are no more the only thing that we need to be concerned with. Actually, the issues of ethics, of power, of societal consequences, our duty as scholars and as leaders of fields and institutions is to those that need to be the next generation creators, the next generation inventors. Nano is here to stay, and so is AI, and neither of them are powerless technologies. They are actually very strong, influential technologies that can dictate our direction of travel for our global society. So, thus, as sensors become embedded in everything from homes to bodies, the face of engineering needs to change. The way we think about our role as engineers will need to change so that our engineers of now and the future will be able to address human basic human needs and improve quality of life. I think we've heard that, such a very strong message from our previous speaker. In 2022, the UK government recognized that without a political stance, engineers will carry on doing what they do best, solve problems as they see them, right within their inner focus. What was the technology solution that they need to be seeking that's in front of them. So they took a political drive and they said, actually, the face of engineering, the nature of engineering needs to change in the UK and globally. They put together tomorrow's engineering research challenges. This is what they told us, which is very, very different from the concerns that we had as a sensing community all the way back in the 1990s. They told us that actually what we need to do is make sure that we promote inclusive engineering all of the time, in the way we work, in the way we teach, in the way we expect our teams to be formed. They told us that we need to strengthen research collaboration because as individuals, as professors, as single institutions, and as single countries, we are not likely to keep abreast and keep a pace with the development of technology that needs to be put to good use and to good impact. They told us that we need to consider how to re-engineer the discipline to transform practice so that engineered solutions are more inclusive, adaptive, and that they respond to global challenges rather than private, small economical interests. They told us to enhance our professional impact, to carry out research that's not so much about curiosity, but about practicality, about the effect of that research in production, in practice, in society. They told us that skills are a very, very important component. Upskilling the profession continuously, it's a need. Technology advances, AI is with us, sensors, let it alone, go from macro to micro to nano. Engineers that we have produced and put out into the society and industry 10 years ago will already need upskilling by now. And they told us to inspire the next generation, because without that inspiration, we are not going to have the healthy, ethical body of engineers that we need to in order to protect our society and ensure that we work for its good. So, re-engineering the discipline, and I probably need to stop, I don't know if I have time for more. Science from nature, the science of nature, and the science of human systems. Bring them together with the technological solutions that we might have had from yesterday and produce the societal solutions for tomorrow. Systems thinking is something that it's not new per se. It was all there before, but is now called upon in order to provide the balanced approaches to wicked challenges that we have. Rethink and prove efficiency, relying on solving or solely on provable systems can limit creativity. So think about non-hierarchical, resilient solutions, because the world is moving too fast and the problems evolve far too rapidly for us to be able to solve them forever or future-proof them with the fixed solutions that engineers used to deliver in the past. So I am going to stop here with a call to action for us all to partake into inclusivity, into international collaboration, and make sure that our engineering profession is future-proof in the age of nano, quantum, and AI. Thank you.